Today, we start a new chapter called Complex Numbers. While the concept of complex numbers has been around for a few hundred years, it is still probably going to sound strange and new to you. This is because, up to now, you've always been told that you cannot take the square root of a negative number, and every number that you square must either be positive or zero. Mathematicians in the 16th century invented this fictitious number called I equals to square root minus 1 to help them solve equations with no real roots. At that time, nobody believed that this number would have any real-world use other than for easing computations involved in solving certain equations. So everybody viewed this new number as a pretend number invented for convenience sake. But this changed in the 20th century. Complex numbers are now used a great deal in modern science and mathematics. One reason for this is that they make the topic of analyzing and understanding modern concepts like sickness much easier. This may seem odd at first because the concept of using a mix of real and imaginary numbers to explain things in the real world would seem contradictory. But once you've gotten used to them, they do make a lot of sense. The real issue is to first begin understanding what they mean and how to use them correctly in the first place. To help you get a clear picture of what they are and how to use them, let's take a look at section 1 of your notes. We begin by looking at the definition of the imaginary number I. I is defined as the square root of minus 1. Now this definition has implications to how we look at numbers and how we solve equations. For example, we can now take the square root of a negative number. Square root minus 4 in your notes can be rewritten as square root 4 times minus 1. And by rewriting the entire expression as square root 4 times square root minus 1, this becomes 2i. Likewise, I can take square root of minus 3 to get square root 3 times minus 1 equals to square root 3 times I. Square root minus 12 can also be rewritten as square root 4 times 3 times minus 1 to give you 2 square root 3 I. In example 1, we want to find the roots of the equation z squared equals to minus 1. Now the thing to remember here is, we can now say that square root minus 1 is a number. We can now write this number as I. In A, you're told that z squared equals to minus 1. Naturally, we want to take square root on both sides. If we take square root on both sides, we will end up with a plus minus square root of the number minus 1. And remember, minus 1 is now I. So we can now write down z as plus minus I. Now note the difference when we were solving these questions previously. If we have x squared equals to minus 1, when we take square root on both sides, we have this. Still the same, but we will say we reject since x is real. For b, we want to find the roots of this equation 2z squared minus 2z plus 3 equals to 0. And using the formula minus b plus minus b squared minus 4ac over 2a, we can simplify this to half plus minus square root minus 20. Now this is the same as half plus minus square root 4 times 5 times minus 1. And then I will get, as my final answer, half plus minus 2 square root 5 I.